Okay, so we can continue yesterday's section, right? I mean, you have some confusion regarding yesterday's section, right? So may I know which point or we need to start from scratch again, right?
It would be great if we can like repeat the same thing.
So Kubernetes installation. Installation have issues, right? I mean, without clarify.
No,
I mean, what about installation? Kubernetes installation using EKCTL.
there are a bunch of commands, right, which we need to follow.
Yes, some prerequisites are there. First, we need to install EKCTL. EKCTL, then this is purely for bootstrapping EKS cluster, okay? EKS service in AWS. And after creating the service, that's fine. We can leave the EKCTL. The next thing when we using EKCTL is deleting the cluster, okay? The same way we can delete the cluster using EKCTL command, like EKCTL. First, we using create command, right, to creating cluster. If we need to delete the cluster, we need to perform delete command, delete cluster, cluster name, dash dash cluster name we need to define here. Also, we need to define the region, the region. Hit enter, it will delete entire cluster. So using a single command, we can set up the cluster and delete the cluster as well. So that's using cube EKCTL. Okay. Then after configuring the cluster, I mean, starting the cluster, we need to interact with the cluster, right? Using API code. So we use kubectl command. Kubectl. It's another command line tool to interact with the Kubernetes. Interact with kubectl. Kubernetes. Got it.
Do we need to install the kubectl too, or it comes as a package with EKSCTL when we are installing?
Sorry, come again.
Do we need to install kubectl too, or does it come as a part of EKSCTL?
No. This is purely different. This is different and this is also different. This
So
is
we
a
need to.
native command actually. Native command line tool for Kubernetes to managing or administering Kubernetes cluster.
Okay.
So for example, if we install okay AWS EKS or Azure AKS, okay, or any of the Kubernetes service or Minikube or Google GKE, Google Kubernetes Engine, or self-hosted. Okay, any of these keys we need to managing after deploying the Kubernetes service. We need to manage, right? For that, we need to install kubectl, the machine where we managing that service. Okay, Kubernetes service. Most probably be installing the kubectl in our local machine. Okay, the laptop coming to organization perspective. And this EKSCTL is purely for our configuration, like the EK setup configuration. That's all. It's a you know using EKCTL, we can simply call creating the cluster like via command line. Got it. So I will show you once again, okay, how to set up a cluster. I'm leveraging a AWS EC2 machine to managing my cluster. So here you can see I have a machine. So in this machine, I installed the prerequisites as well, like EKCTL and kubectl. Also, I attached that role, okay, to managing EKS cluster. Okay. So this is a command, okay. I already installed EKCTL in this machine. So this is a command to set up a Kubernetes cluster. And there is no doubt regarding the command, right? So we are talking with the EKCTL to create a cluster. So this is a normal command.
Can you break
EKCTL.
that down to all the parts, like create cluster, then you have the name, then you have the
Yeah,
then you give the node name, then node type, then managed.
right,
What's
right.
the value in front of managed?
Sorry.
What's going to be managed? Okay. And 3 nodes.
Right. So here we can see the command. Okay, I will
If
write
you
down it.
didn't put dash dash manage, would it be an unmanaged one?
I will explain. So this is the EKCTL command to create a cluster, a Kubernetes cluster. So EKCTL create cluster dash dash name. Then we need to define the name here. So any name we can define. I'm just using EKS dash 3. Okay. Then we need to define the region. Which region we are going to deploy the specific cluster. So we need to define the region as well here. Any region we can define. Then the node group name. So here I use the node group name as my node. Node group name means finally we will deploy 3 node, right? So this is the node 1, node 2, and node 3. So these all the nodes belongs to a group actually. That group name is my node. Got it. That we define here under the dash dash name. So in dash dash node group dash name. Then node type. So here we install different EC2 machine, right? So we need to define the machine configuration as well. So under the dash dash node type, we need to define the corresponding family of that machine. So these machines are in T3 family, T3 family, and the configuration is T3 small. All are same. T3 small, T3 small, T3 small. Then dash dash manage. These are the machines. These EC2s are all the EC2 machines managed by dash dash manage means it's managed by AWS. So all that, I mean, coming to the mission perspective, they will patch the mission, okay, security patching, and they will purely managing this mission as well, AWS. Then node dash dash node that there we need to define how many node we need to set up the Kubernetes cluster. So in this case, it's 3. So we will get 3 mission, 3 easy to mission or 3 node 1, node 2, and node 3. Got it.
So in terms of dash dash managed when we are like working with a VS Code? Do we need to specify as AWS?
No, because we are going to create EKs, right?
Okay. Then
EKs
why
means
do we need to
EKs.
give as managed?
This is an Amazon specific command, Elastic
Yes,
Kubernetes.
Elastic Kubernetes. It's actually
So it would be
managed
have
by
an
AWS.
equivalent in Azure and Google.
No, I agree. I agree. Then why, since it is an AWS, why do we need to give the flag as
Yes,
managed?
yes. This is for node group actually. Okay, not nodes only for this managed one. For AWS, okay, this is the master part. Okay, so this is the master part. By default, okay, master part, all the master parts components managed by AWS. Okay, there is an optional case for the node group actually, or node. We can set the node, these are the machines actually, these are the worker part machines, right? So the
Mhm.
worker part machines we can set to AWS to manage, or else unmanaged as well. So in that case, if we set unmanaged, then we need to manage the machines things like patching the machines, managing the machines as well. If we
Okay.
define here manage, then AWS will care of this mission as well.
Now I got it. Thank you.
So I'm using tender to configure the mission. I installed the prerequisites, okay, like EKCTL and everything. That's why there is no error. Also, I added the role, okay, for the um, permission part. I have created a role and attached to this machine. So as of now, there is no doubt, right, all of you?
No.
So anyone know what is actually working behind this? So
For
actually, what will
creating
happen?
cluster.
Right. This single command, okay. This single command will create first a VPC, a fully functional VPC that include VPC, subnet, routable, routable association, private subnet, public subnet, internal gateway, NAT gateway, lot of things it will create a fully functional VPC for EKS. How this happen using a automation tool that offered by AWS that is called CloudFormation.
CloudFormation.
So using CloudFormation, everything is bootstrapping actually. So we can see that as well. Just to go to the dashboard and type CloudFormation. So we can see that progress as well. This is AWS native automation tool, okay, infrastructure as a code. Similar like Terraform. So here you can see this is the stack that we are currently using. Okay, so the CloudFormation will automatically creating stack actually. So here we can see even update current status. See, lot of things created right for this Kubernetes. So here you can see cluster 3, we define that name and everything is creating the service role, NAT IP, internet gateway, VPC. So here you can see it's created the VPC with all these stuffs. So in this part. These are the stacks it's creating, okay? Different services for the VPC part. Also, we can see the VPC in that VPC dashboard. So this is a VPC. EKS 3. That's the name for our EKS. So the name look like EKS CTL, EKS 3 cluster VPC. Also, we can see the entire resource map here, okay? So these are the security group it created, root table, internet gateway, everything is listed here. So you can see it's created a internet gateway, created an ad gateway, root tables, subnets, 2 subnet created. So sorry, 4 subnet created in different available zone as well. See, one is in 2 is in 1C and the rest of 2 are coming under the 1F. So here we can see the public root table, private root table.
So in the similar fashion, Azure and GCP still have the same stuff like something similar to this kind of command
All
wherein
the
it will
cloud
be
providers, all cloud providers have their own native automation tool.
okay. So
AWS.
which will take care of the creating. Even I have the question of like whenever we creating the T3 micro, right? I'm about to ask you how about the VPCs and subnets. So cloud formation is taking care of it. Okay.
Yes. So we called as ARM, okay, for the Azure part. Similar like CloudFormation, Azure have their own automation tool, that is Azure Resource Manager. GCP, I forgot the name actually. Once a native service there actually for automation. But we did not configure, I mean, we didn't concentrate on any cloud providers automation part actually. For example, if we learn CloudFormation, okay, currently we work in a AWS environment and we learn CloudFormation. That's fine, but whenever we switching job, okay, the next environment will be Azure, right? In that case, we stuck actually because we did not learn the Azure Resource Manager. Because using CloudFormation, we can't do anything in Azure, right? So for that, the common tool that is called Terraform. So if you learn Terraform, we can apply Terraform in AWS, Azure, and GCP as well. Or the other services that using Terraform, we can leverage the Terraform for deploying the resources. Like for example, AWS, Azure, GCP are cloud services, right? So some other services, for example, Datadog. Datadog is a monitoring tool, okay? So in this case, for Datadog as well, we can leverage, I mean, we can configure Terraform. That means using Terraform, we can set up some configuration in Datadog. Good.
Got it. Why is it taking too much time? Yesterday it didn't take much, right?
Cluster creation, right?
Yes.
It will take 10 to 20 minutes actually.
Yesterday it was quick, right?
No. Same time. What are things it's you can see first it's creating the VPC, then after creation of that, it will create the master node, installing several components there, right? 4 components are there. Then worker node, creation of 3 EC2 machine, and install that components inside the worker node as well. Then it will join in master node and with the worker node. So a lot of jobs are there.
So if you're not taking it, like if you're not going with any of the managed service like AWS and everything, we have to create everything on our own, and we have to like self doing it, creating VPCs and everything by our own, right?
Yes. So the master part is complete. And now it's creating the EC2 machines and
So after the cluster gets created, if we want to increase the count of the nodes, is
we
there a
can
way
scale,
to
scale up.
we can't edit the cluster, but is there a way to edit the cluster, or how we gonna do that?
No, we can scale node count as well. For example, as of now, we have 3 machines, right? So we need to add one machine after deploying the clusters. Yeah, we can do that.
Is there another command to do that, or how does it
Yes,
go?
yes, yes. It's another
So
command.
if you are doing that, it's gonna again update the cloud formation template, or
Yes, it's updated.
okay.
Has
Yeah, it's completed. This is the core kubectl version getting Kubernetes kubectl. The cluster is completed. See. So whenever we in Kubernetes cluster, we need to update the context of kubeconfig file. Okay. So kubeconfig file belongs to EKS. See, now we can run the kubectl command. So this is the Kubernetes configuration command. Okay. So using AWS EKS update kubeconfig, we will added that context, kubeconfig context in our EC2 machine. So then after that, we can manage the cluster actually using kubectl command. So that context will under the root directory of our EC2 machine. So here we can see the context as well. Yesterday I show you, right? In cat, we can see that file as well. So this is a Kubernetes configuration file. So we call as kubeconfig. So it's starting with the API version v12 command AWS ending with. So inside this file, we can see everything related to the cluster. Okay, every details. This is the same file we used to for integration whenever we creating CI/CD pipeline. So as of now, there is no port. You can see. So all clear, right? As of now, all of you.
Yes.
Okay. So what about the application deployment? Yesterday we deployed an application, right? So is any doubt related to application deployment? So here we can see the namespace as well. Okay, different namespace there. By default, if we deploy any application, all the application pod and container will create under the namespace default. Okay. So if we need to create a separate namespace, and we can define the separate namespace as well whenever we deploy application. So I will show you how to create a namespace and deploy some application inside the namespace. So kubectl create namespace short form ns, then the namespace name. Yes, no. See, the namespace is created here, right? So we need to deploy some application.
I think Mark has a doubt.
Yeah, Mark. Please.
Thank you. I just want to ask, what does the namespace do? What does it do?
Okay. Namespace actually it's a simple logical area. Okay. So, for example, coming to Kubernetes, give me a second. Okay. So coming to Kubernetes, we are going to deploy some application, right? Now the cluster is up and ready, and we can see the namespace as well. So I told you, coming to default namespace, every application goes to default namespace. Okay, namespace is nothing. It's a separate separate logical area. Okay, it's a separate logical area, and in that specified area, we deploy the application. So the container will create here. Not container, actually the pod. Okay, inside pod we can see the container as well. So the application is here. So this logical area we called as a namespace. So some requirements are there. Okay, so we have a Kubernetes cluster and we have different clients are there, like Apple, that's one of the client, then Orange, another client. So we need to deploy their application to our cluster, right? So in that case, we will create separate namespace for deploying client application. So we created a separate namespace for Apple, like creating a separate namespace, Apple, and create another namespace for Orange. And we will deploy their application. Okay. Whenever creating namespace, we can see a namespace like this. The namespace name, Apple. Okay. And for the Orange, we create another namespace, Orange. And we deploy the application, corresponding client application to the specific namespace. So this is a isolated or independent working environment. Okay, so different peoples can work different namespace as well at the same time. So some developers or some dev teams working on specific client application, right? So they can assign the namespace as well. So they will work with logging with the corresponding namespace and they work. Got it?
Thank you for that. So it means that, like, where we deploy the application, maybe we deploy it at the development stage or production stage or UAT stage. These
Right,
are
right.
the these are the
Yes,
namespaces, right?
yes, that also we can define. For example, we have a different environment. Okay,
Okay.
so UAT, dev, prod, like that. Not using prod actually. Yeah. Similar like environment, we can create different namespace as well. Namespace one for the UAT, namespace second for the dev, like that. It's a like a virtual isolation of application or logical grouping. So the corresponding application will deploy under the namespace. For that, we need to create a namespace and we need to define the namespace as well whenever we are applying YAML file. So that I will show you.
Thank you.
I have one question.
Hmm.
So, is a namespace like different clusters, or is they like logically separated clusters?
Logically separated, that's all. Not separate actually.
They're not separate machines.
Not machine. It's
Cluster of machines, separate cluster of machines.
just for example, I will show you. Okay, like, in uh, coming to a simple explanation, I will give you. Okay, coming to Windows. Okay, Windows computer. We just open my computer, right? So we can see different drives there, like C drive, D drive, E drive. So consider we open the D drive, we can see a lot of groups there, right? So not groups actually, different folders, right? So when opening one folder, we can see some stuff related to the folder, like films or music like that. So another folder, we can see some other files or similar like videos or music. This is different folder. Okay, coming to Kubernetes, we can define namespace as different folder. Okay, similar like that, and we will deploy the corresponding application to inside the folder.
So it sits on a different disk space, the namespace.
No, not disk
Just
actually.
a different.
But yeah, only the folder part, taking the folder part only. Okay, I'm using a sample YAML manifest, okay, to deploy some application. So here you can see the deployment API version. Okay, the API that we use for Kubernetes, that is named version. Okay, that is why it's came with the app v1. Then the kind is deployment. So it's ensure the replicas is running fine and everything seems good within that application deployment. Then the name for the application. Okay. Then here we define the name for the deployment, and coming to the application name, we need to define here. So replicas is 2. I will change it to 5. Okay. So we can see 5 pod running with the 5 container. Here again, we need to define under the match label, we need to define the application name. Also the label, we need to define the application name here. That's fine. Then coming to container part, we can see the container name and image name for the application. Image pull policy. This is image pull policy means we can define the image pull policy. Okay, so here it's defined as always. So every time it will pull. Then container port 3000. This is a Node.js application. That's why using the port number 3000. So I'm going to apply. So if I hit enter, okay, like this command, Kubernetes apply. Sorry, I did not define that file name. So we need to define the file name as well, deployment.yaml. Okay, that I mean actually. And if I hit enter, this application deployment goes to the default namespace, this one. So here we created one namespace here, right? GS new. So we need to, if we need to define in the same command, then the application goes to the mentioned namespace. So we need to define using -n for the namespace definition. Then type the name of the namespace that we created. So this application goes to the GS new namespace. Doc, now its application is deployed. kubectl get node. We can't see the pod actually because we need to define the namespace as well. Now we can see the message, no resource found in the default namespace. But our application belongs to this namespace. So we need to define the namespace as well, -n gs new. Now we can see the application is deploying and we can see the container is under creation. Okay. It will take some time. Now you can see 0 by 1. Whenever the ready state 1 by 1, that means the container is up and running. Yeah, now can you see it's up and running. For the same, we need to create a service. Now the application is deployed inside the cluster, but no one can access the application. Only we can see that kubectl get service. Okay, how many services are there in our Kubernetes cluster? You can see only one service there. That is the Kubernetes default service. Okay. So also the type is Kubernetes cluster IP and the IP address using for that 10.0, 100.0.1. So if we need to expose this application, okay, outside the Kubernetes, we need to create a separate YAML, separate service for our specific application. For that, we need to write the service definition or service YAML file as well. So using nano service.yaml. So this is a service YAML. Okay. So the API is the legacy version we define here by V1. And the kind for the application, we use the kind as deployment, right? For this, we use service. So the Kubernetes know whenever we apply in this file from a local machine to or the EC2 machine to the API server, okay? Kubernetes API server taking the file, right? This file. So whenever it's looking for the kind, it's service. So that Kubernetes know this is for a service creation. Also, we need to mention the application, okay? Which application we need to create this service, right? So also we need to define that under the selector. So under the selector app, we define the application app, the application name that we define in that deployment file. Here also we use that service type as load balancer. So it will create a load balancer for us. Then the target port. This is the container target port and this is a port that we use for load balancing, port number 80. So also coming to the load balancer dashboard, we can see there is no load balancer as of now, right? But we have created a file, but we did not apply that one. So I'm going to apply. Whenever we are applying that file, you can see the load balancer will create, okay, automatically because we defined load balancer under the type, service type. So I'm hit enter. See, it's created. Now we can check the load balancer dashboard. See, it's created for our deployment. It's a classic load balancer, okay, application load balancer. And also we can check the service. It's not showing here. Why? Anyone can?
Namespace.
Yes. We need to define the namespace as well. So everything related to the namespace. Okay, if we define namespace for deployment or creation of service. So any doubt? Or now it's clear, right? All of you.
For me, it's clear.
Okay. Okay, application is deployed. Say clone of YouTube or something like that. So all good, right? All of you.
Yes.
Then we can continue tomorrow to some other topics like Kubernetes. Some deep topics are there. Like
So if you
topics.
want to delete the cluster, just give
Yeah, that I will show you.
EKS CTL delete.
What autoscaler deployment strategies. Okay, two topics are there. So that I will cover tomorrow. Okay. So deleting the cluster is simple. Okay. And now you can see what are the components or what are the services for this cluster. Whenever we installing the Kubernetes, so it's creating from VPC, right? From VPC load balancer there. Now we created load balancer. Also, we can see by manually we can check, okay, what are services created. Go to the VPC. And here we can see NAT gateway. So that it will create a NAT gateway actually. So this is a NAT for EKS cluster. And Elastic IP as well. Whenever it create NAT gateway, then we need an Elastic IP, right? So this is Elastic IP actually. Then lot of service there. Subnet, route table, inter gateway. So this is the inter gateway. So using a single command. Also, I show it right, the load balancer. So all these things we can delete within a single command, that is using EKSCTL. Okay, EKSCTL. How we will create the cluster? EKSCTL create cluster, right? For deletion, EKSCTL delete cluster.
Yes.
Delete cluster. Then we need to define the name of the cluster. That is EKS3, right? Then we need to define the region as well. That's all. US East 1. This is the command to delete entire thing. Correct. Hit enter. It's starting to remove everything. Like the load balancer, the VPC, the master part, the EC2 mission, everything will going to destroy.
So
Till
it's
take
going to again use the cloud formation template to.
right. This will take 10 minutes actually, 10 to 15 minutes as well to delete everything.
Agree. It took 10 to create a, yeah.
Yes. Okay, any doubt? All clear, right? All of you.
The like the commands. Documentation related to commands.
Yep, I will share. I'll give you one task as well, okay, to deploy a Kubernetes cluster from scratch and deploy some application. So you can try it in your account, all of you. And so we can, yeah.
Other time I need to have the reference of this one. Video.
The video, right? Yes. I shared the videos. Yesterday videos also I shared. She will upload today, I think.
Okay.
So we can wind up, right, all of you?
Sure.
Sure.
Tomorrow we will go through some other topics related to Kubernetes, okay? That scaling methods, how scaling happening in Kubernetes, scaling in the sense of horizontal pod autoscaler, okay? From the application perspective, we need to scale up our working pod or working container. So we use one resource type in Kubernetes that is pod autoscaler, horizontal pod autoscaler. So tomorrow we will implement. If you have time, then I will show you the deployment process, actually, deployment strategies. Or else I will take separately, okay?
Okay.
Then we can wind up, right? All of you.
Sure.
Okay. Thank you for the class. Have a good morning, sir. Good night to everybody over here.
Bye.
Good night.
Speak well.